Hi, this time I wanted to just start long story short. So I will make long story short and provide some informations in form of notes also to myself. Yes. So lastly, we were talking about forces and acceleration, and additional note regarding the acceleration, so the kinematics. So we know that we have state of the vehicle, and together with orientation we can describe the position, the velocity, acceleration. So actually starting from the position, so the velocity or speed is first derivative of the position, so the acceleration is second one, and what we have later, and how it works actually. So we know that velocity is the speed, and it's the causing a displacement. So we move from point A to point B. So we displace meters in time. Acceleration is like if you accelerate 1 meter per second square, so 1 meter per second, so that change. So starting from the rest, so from zero velocity, in the first second we have 1 meter per second velocity. In second we have 2 meters per second, so we are increasing velocity, and same can happen to acceleration. So that change in acceleration, so what is the change of acceleration, because we can also accelerate faster, not just constantly 1 meter per second. But we can change that, so this is the jerk, and this is the first moment of acceleration. So if we are in the car, the force is getting at us into the chair, and the same deceleration is when we move forward, so with the reverse force. So again, after the acceleration there is jerk. Fourth derivative of position is snap, then is crackle and pop. So we can measure the rate of change for very rapid movement to sixth derivative of the position. So probably this is for rockets, maybe, I'm not sure. Yeah, but mainly for drone, the important is the minimizing the jerk. So having actually smooth acceleration, not just something that is not managed well. So minimizing the jerk. Yeah. So that was information I wanted to say, and well, maybe in addition, because currently I will be I will need more time and having time on statistics and the filter. So the goal is to work currently on unscented Kalman filter, and that requires some updates on the statistics, and for that I can show you 3 files from the GitHub. So you know the place in GitHub, and actually there is basic math. So from that actually, well, what will be used? So mean, variance, standard deviation, but covariance, and probably that should be length -1 to calculate covariance. So mainly I will be around that part, and what we can say, the covariance is the relation between two random values. So like for drone probably we can we can measure some changes between within the state, like maybe speed, acceleration, the position, and I'm not sure about the orientation, but yeah, so that is the goal, to understand that better. And yeah, that one, and the estimation actually. So the estimation, this unsettled Kalman filter, Bayesian, Gaussian filters, those topics. So I will try to provide some examples next time. And what I wanted to show also, that is in FC Toolkit in tests. So what will be needed besides the estimation is pitch control or sliding mode control. And just shortly, so pitch control is like proportional integral derivative. So actually we are minimizing, or we're calculating the proportional, so the main error, and how it fluctuates with derivative, and with integration we are trying to minimize the cumulative error, so like some drift. And one thing about the sliding mode, there are some papers on super twisting sliding mode, or something like that. So it's also interesting, and I was also checking how it behaves, and it is implemented as well. Actually, the tests. So to have the intuition and the feeling how it works, with some starting and the goal value. So we are trying to approach the goal, and the nice thing is that this structure have a pointer to function update SM, and this update SM function use the sliding surface function, and you can see that there is signum 0, and you can check how it change the calculations if you for sliding surface change signum 0, which you can find also in basic math, signum 0 to signum 1, this function. So you see that for values greater than 1, it returns 1. For values lower than -1, it returns -1, and between 1 and -1, it returns the value. So the sliding surface, so how actually it is parameterized as well with surface lambda, so the sliding surface coverage convergence rate, and it gives interesting results. So probably that will be checked, but the main goal is filtering with Kalman to have appropriate position, velocity, and acceleration measure. And then there will be so second part, it will be pitch control actually, and after that sliding mode. But it is interesting, there is also model predictive control, but that's not for now. I think that pitch control is main part, and sliding mode can be checked as well. Yeah, and everything is flight control common in the static. Okay, cheers.